Hello, good evening, everyone. My name is Enevena Solomon Spencer. I'm a student at Macquarie University doing software engineering. Yes, so this is a continuation of the previous video that we talked about facial recognition in the field of security. Let me just share my screen real quick, and we begin today's presentation. So, today I'll be talking about. This is just a continuation of the previous videos I've been talking about the facial recognition in homes, banks, and police. So just like you can see, yeah. So here, these are some of the contents of this presentation. Which I'll be looking at all those that you can see right there. So beginning with the problem to be investigated. Basically, the problem to be investigated is seeing a way how we can improve the security in homes, banks, and how to help the police in their department. But some of the problems that arise from that, for me, is what I was talking about. Basically, I wasn't looking at the problem statement or something. So we have loss of property, the loss of lives, pending cases due to lack of evidence. You know that in courts there are many pending cases that can't be closed because there's no evidence. Yeah. So the background of AI and accountability, I've been talking about accountability before. And we say that with accountability is the expectation that organizations or individuals will ensure proper functioning throughout the life cycle with the AI systems that they design, develop, operate, or deploy according to their roles and applicable regulatory framework, and for demonstrating this through their actions and decision-making processes. Yes, so basically that is, and this is just a brief background of AI. Yeah, and it's with these things that we keep building on to make much better systems that are of great importance. So bringing to the significance of the project, the principle of face recognition technology continues to build security solutions. Facial recognition is recognized as one of the most accurate and easy ways of establishing individual identity across the wide range of sectors in our day-to-day activities. So facial recognition is used when issuing identity documents. So you can find that even in our daily lives, on phones, on all those things that at times they assist in security purposes. Like if at all you're accessing your phone, you can either access it via using a fingerprint, that's for a smartphone, or you can face ID for iPhone users, iPhone lovers. Yeah, so the face match, all these are some of the things. Actually, I also have a concept paper that I'm working on, and just like you can see, it gives a much more detailed approach of what I'm talking about. It has everything that is concerned with that I'm talking about in this presentation, and most of the things I haven't included them here, but they're in the concept paper. Yeah, so in case you get time, you can just read through. You can just pause the video and go through some of my work. Yeah, I'll be glad when you leave a like or subscribe. Yeah, so proceeding, we have the AI project scope. What is the scope of our project? So the scope of this is, remember, the scope varies from project to project. Basically, what my project is about, find it's still facial recognition, but it is not the same like what other people may want to use facial recognition for. For example, here I was giving an example of Snapchat that you may go and Snapchat has filters that they have to first identify your face and so they can apply the filter. So that is a very different, their scope is quite different from what my scope is. And when you look at my previous presentation, I was talking about some of the things that we shall be needing in this project. And with all that information, you can be able to tell the scope of this project. Yeah. Then we have the problem statement. Here we're looking at the concise description of the issue to be addressed or a condition to be improved upon. And it goes ahead to identify the gap between the current state and the desired state of the process or product. So face recognition has many challenges due to illumination variations like dimensionality, uncontrollable environments pose variations, aging effects, and you may find you're tilted, your face is kind of tilted to one side, yeah, and among others. So that so I'm saying that, and this is the current state conditions that is to be improved upon to turn into what we expect the desired state to be. So we are trying to make this AI so that it can be able to go through to be able to, how can I say, to go over some of those challenges such that we can get something that is really of great importance and something that functions very well. So the factors mentioned above are capable of affecting the project, but we can adjust the frames. The frames, I mean, like those that identify where your face really is, and so that they can give you like maybe the side view, the front view, such that in case the person is maybe coming to your home from but facing in a different direction, at least it can pick the side view and notice whether this person is a stranger or a new person, yeah, and take the necessary security measures. So the AI research questions, these are some of the AI research questions. I talked about them in my concept paper, and I answered most of these. So some of the research questions are in facial recognition, racially biased. Yeah, so some of these questions are pretty obvious, and at times they are quite challenging. Yeah, because I also didn't know. Yeah, some of the answers I actually got them from some of the websites. I'll be showing you my reference, and they guided me to understand this much in a better way. So interpretability has to do with how accurate a machine learning model can associate and a cause to an effect. Explainability has to do with the ability of the parameters often hidden in depthness just justify the results. So what is the hypothesis? Hypothesis in machine language is used when in a supervised machine learning, we need to find a function that best maps input to output. This is also called the function approximation because we are approximating a target function that best maps a feature to a target. So basically that is, here we are trying to see what feature that can map an input to an output. Basically that is what hypothesis in machine language is all about. And here I got this text from one of the on Google, yeah, that says that the expert hypothesis suggests that the mechanisms involved in the first processing are also engaged by objects with high within-class similarity, which people have become experts at rapid individuation. Evidence cited in support of this view comes from studies with the real-world experts as laboratory-trained experts. Yeah, so that is basically that is it. That's what the hypothesis is. So we have the research objective. Yeah, here we are looking at the interpretable representation learning. Understanding the visual recognition has a long history in computer. Back then, most models were used handcraft features. A number of research focused on how to interpret the predictions. So here we're just looking at some of the, but paths and calculation in face recognition works constructing meaningful representations mostly aim to improve the recognition accuracy. So we have talked about a dataset description, and I remember I told you that a dataset in machine learning is quite a simply is a collection of data pieces that can be treated by a computer as a single unit for analytic and prediction purposes. Yeah, so basically you find that a dataset has features, has the data that you're going to be training the model with. So interpretability can be part of the objective. And with interpretability, we look at how the model came up with these results. We are looking at, we don't care, we don't look at what it really did, but like we want to know how like it came up with some of these results. That is basically what interpretability is. And the proposed AI methodology, we have data collection. Basically, that is just a brief. And some of the things we look at are accuracy, relevance, quantity of data needed, variability, and ethics. Then we have data exploration. This is when we're understanding and describing and visualizing the data that we have collected. We have data preparation, and basically that is it, trying to organize our data so that it is much easier to work with. Yeah, then we have model training the model, and and some of now, for example, for this case, we shall be saying that for the training, one option is called 3 times on each of the anchor positive and negative image, and then give the value to the loss function. So you find that here we are saying that when you're training this model, we are going to have whether the image is correct, whether it's not correct, and the model will be able to identify whether this image belongs to this category or this other category. So we have the model testing. Here we are just basically testing the model to see whether the results that are coming, that it's giving, whether it can be able to give results. Then model evaluation, here we assess how well the machine learning approach has worked, and we can look at the predictive accuracy that is got from the correct predictions that the model has made out of the number of total instances. Then lastly, we have the actionable insight, and this is to do with explainable AI. So we see that based on the results, whether we can deploy our model for production or not. So these are some of the references I used. I encourage you guys to have a look at some of these websites, and have a nice time. Please subscribe. Thank you.